Hey guys, today we are looking at probability. So the probability of an event is the measure of the likeliness or chance that an event will occur. So two different formulas here. We have theoretical probability, which is what should happen, and then we have experimental probability, which is what actually happens when you run a trial. So with theoretical probability, it's the number of favorable outcomes over the total number of outcomes. So what you want to happen over the total number of possibilities. With the experimental, it's the number of times that actually happens, the successes, divided by the number of trials that you do. So as we are looking through some of these, if you have a spinner that has 8 equal size sections, well, there are 8 different options that could happen there. So that would be your bottom number. And spinning a 6, how many of those spaces, those sectors, are a 6? Well, only one of them out of a total of 8. Spinning a number greater than 5, well, that could be a 6, a 7, or an 8. So there's 3 out of a total of 8. All right, you and your friends designed t-shirts with silk screened emblems, and you are selling the t-shirts to raise money. The table below shows the number of t-shirts you have in each design. A student chooses a t-shirt at random. What is the probability that the student chooses a red t-shirt? Well, the red t-shirts, in total, there are 12 of them, if we don't care whether it has gold or silver. So there's 12 red, and we have 18 green, so total shirts we have 30. 12 divided by 30 will reduce. They both divide by 6, so 2 over 5 would be our reduced fraction there. All right, another spinner problem. Each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results. For which color is experimental probability the same as theoretical probability? Well, theoretically, we should get it for 1 out of every 4 times. So as we're looking through here, we spun it 20 times. This is 5 out of 20. 9 out of 20, 3 out of 20, and 3 out of 20. So which of these numbers is the same as 1/4? And that would be our 5 out of 20. So our answer would be red. Okay, 5 cards are drawn from a standard 52 card deck. What is the probability that the first 2 cards are red? So we want the first card to be red and the second card to be red. So since we're talking and, we're multiplying here. So if we draw a card out of a deck and we want the probability that the first 2 are red. Well, how many red cards do we have? We have 26 to choose from out of 52. And then if we draw a red one, we only have 25, and we only had 51 cards if we're not replacing them. So if I multiply that, I get 25 out of 102. Or you get approximately 0.245 if you write the decimal approximation. All right, 9th graders must enroll in one math class. Find the probability that a randomly chosen student from this year's 9th grade class enrolled in consumer math. So it looks like we have 38 students that enrolled in consumer math out of a total of 87 plus 38 plus 69 plus 51 out of a total of 245. So 38 out of 245 does not reduce, so approximately, if you wanted the decimal, would be 0.155. Algebra 1 or Intro to Algebra. Remember with or we are adding. So Algebra 1 was 87 over 245. Or Intro to Algebra was 51 over 245. So we get 138. Which also does not reduce, but approximately 0.563 if you want the decimal there instead. Okay, for a town parade, you will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first, and the float with the school chorus is second. So if your float is first, there is a 1 in 12 chance that it's chosen that way. And then since yours is first, there's one school chorus float out of 11 remaining floats. So we get 1 out of 132 would be our probability. All right, a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There's room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top? So you don't care whose photo is placed at the top, or whose photo is placed first. You just want the 2 of yours to be placed. So, we have 14 photos. We have a spot for 2 at the top. So, we have 2 that we could pick out of 14. And then if we pick one of them, then we only have 1 out of 13 left. So we get 2 out of 182, which reduces to 1 out of 91. And you can get the decimal approximation for that if you would like as well. Okay, a little more complex here. We are looking at television game show. 9 members of the studio audience are randomly selected to be eligible contestants. 6 of the 9 eligible contestants are randomly chosen to play a game on the stage. How many combinations of 6 players from the group of eligible contestants are possible? So if we want to choose 9, or we want to choose 6 people out of 9, how many different combinations can we choose? So taking us back to 9, select 6 where order doesn't matter. So this is not probability. There's 84 combinations. You and your 2 friends are part of that group of 9 eligible contestants. What is the probability that all 3 of you are chosen to play the game on stage? Okay, so total options, there's 84. But out of the 6, how many of those possibilities are 3? Or are of you 3? So 6 select 3 would be 20 out of 84, which reduces to 5 out of 21. So the probability that all 3 of you are chosen to play the game is 5 out of 21. Okay, find the probability that a randomly thrown dart would hit the shaded portion of the target shown below. So the figure inside the circle is a rectangle. Okay, so we want to hit the shaded part. We want to hit everything outside the rectangle. So if I'm writing this out, I have area of the circle and I need to take away the area of the rectangle. But that's over the entire area of the circle. That's the entire probability, or that's the entire area that you have to choose from. So area of the circle I know is pi r squared. So pi times our radius here is 10, minus the area of the rectangle is length times width, so 12 times 18, over pi times 10 squared. So I have 100 pi minus 216 over 100 pi. Now you're not going to get a good fraction out of this because you're dealing with pi. So I get 98.16 is my top number divided by 100 pi. Now be careful that when you divide, you're dividing by 100 and dividing by pi. If you don't put those in parentheses, it'll try to multiply by pi depending on the calculator you're using. So I get about 0.312. So around a 31% chance that you would hit the shaded part of the figure. Alright guys, that's all I have for you today. If you have questions, feel free to come in and see me. Otherwise, I will see you in class.